Good morning everyone. Today I am going to take your first year BSc Electronics subject. Myself Rupa Kulkarni. This year I am going to handle the BSc first semester Electronics in the academic year 2020. Right? Today in this session I am going to explain about the introduction of an electronics, definition, applications and the components. What are electronic components? I am going to explain in this session. First, in the electronics meaning, in the all over the world they can call it as the electron mechanics. Electron mechanics means what? Electron you have already studied in your PUC. In a small particle, we can call it as an atom. In that atom, positively charged particles, we can call it as a electron, and the negative call it as a electron. Positively charged particles are called it as a proton, and negatively charged particles are also called it as a electron. Mechanics means what? Movement, motion, we can call it. Electron plus mechanics, electronics. And the particular definition of the electronics is the branch of a physics or an engineering which deals with the current conduction through a vacuum, glass or a semiconductor is known as electronics or movement of electron. I have already explained it. Electron plus mechanics, motion of an electrons. Movement of an electron in a semiconductor or a conductor or a vacuum or a gas is called it as a active components and passive components. They are the two types of the components in electronic devices. Means active name itself is telling the active. Active means more active. Active components, the particular definition is can inject the power into an electric circuit and are capable of electrically controlling and amplifying the flow of electrical current, whereas passive components. Example, diodes, transistors and integrated circuits. The same way the active components means the name itself means active. Active means giving the more energy. These components are giving the energy to the circuit. Like transistor, used for the amplifying the electrical signal or as switching devices. Means amplifying the means the increasing the signal strength. For example, in your mobile phone, FM it is there. It is the sounding the very less. It is the you can using the antenna through increasing the signal strength. Or if you are dancing on a big stage, your mobile phone is connected to the amplifiers. You can give the more energy, more sound for that one. That is the using for the amplifying the circuit. Diodes. Diodes is the using for the rectifiers. Rectifier diodes means conversion of AC to DC. For example, in your solar energy they are giving, and the batteries, charging batteries are conversion of the AC to DC. It is called as a diodes are using for the conversion of AC to DC. And the next one is the IC. IC means integrated circuit. In your before days they were using the big components they were using. At present days ICs are using means that it is the minimizing the electronics devices sizes and easy to handle that. They were using the telephones in those days. At present days mobiles are using because of the ICs. Display. Your mobile display and the TV display in your further days, in your many of the ago, they were using the black and white TVs and the color TVs with the big box. At present days, they are using the LCD and the LED and the small displays they are using. LCD means liquid crystal diodes, LED means light emitting diodes. They are using at present days in the TV display. In the before the days, they were using the CRT tubes, means cathode ray tubes. It is a huge hollow tube. Displays are minimizing because of the LCD and LED. Passive components. Passive components, it is the name itself is a passive. Passive means what? Restrict. These components in the electronics devices like a mother and a father. Like a mother is more lenient, giving the freedom. That is the like a active components. Passive components means like a father. It is a restriction. The passive components is a particular definition is can influence the flow of electricity running through them, either consume or store the energy. Means that store the energy or it controls the flow of current or a flow of voltage in the circuit. What are those? Those examples are resistors, capacitors and etc. Resistors means what? Register the meaning, it is the register the flow of electrical current in a circuit to lower voltage. Means you are giving the 5 volt, it controls how much it wants to your TV, it will provide automatically, depends on the resistor value. Next is a capacitor. Capacitor means store the electrical energy and can replace it later when needed. For example, in your TV, if you on the TV, the LED will on. If you turn off that, it takes some more time to off. Some more time to off that one light LED. Means it is charging. It holds that after turn off all the circuit in the TV, then it will turn off. That time it holds the charges. Next is inductors. Inductors means store the electrical energy in a magnetic field, allows direct current to flow through it, but not alternating current. Inductor, it is also a component to use in your labs and the many of the devices. Next is a transducers. Transducers are converts an input signal from one type of energy into another type of energy. It is called as a using for the sensors. Sensors means, for example, in your mobile phone sensor, they are using just sense your skin, not sense your nails. Means, for example, if you press on that nail, it is not moving, it is not working, it is like that. And it is also a convert the light energy into the electrical energy, like a solars. This is the electrical energy, it converts like that. The transducer is a main role in present days. Now I am going to explain about the registers. Registers are the main component in your laboratories. In your lab, it is the main component. To identify the value of the register is a main link. The first we are going to definition of the register is to control the flow of electricity when necessary, highly linear. As the voltage changes, the current through them changes linearly. Means what it is like that, if you are giving the high voltage to them, it will not allow for that one. How much it wants the device, how much wants it will provide like that. And then ನಿಮಗೆ ಎಷ್ಟು ಬೇಕೋ ಅಷ್ಟು ವೋಲ್ಟೇಜ್ ನ flow ಮಾಡಕ್ಕೆ ಬಿಡುತ್ತೆ. That is the main important of the registers. They are the color code and the multipliers you have studied in your PUC also. Once again I am going to explain to you. These are the color codes. BB Roy goes to Bombay via gateway you have studied. First color band is the first and the second digit is a band. third is a multiplier. After the gap, whatever the color will come, it is called it as a tolerance. First I am going to take the first color is brown, green, red. Sorry for that, golden I have not written. It is take it as a golden for the tolerance. Brown is a number 1 in the first column. Green is also a first column, number 5. We can take it as a 15. And the next one is a red. Red is the power you can take for that one because of the third band. It is 10 to the power 2 equals to 100. 15 into 100 equals to 1500. It is converted into the kilo ohm, 1.5 kilo ohm. It is the color band you can calculate. And the second example is the brown, green, black, orange, gold. 5 colors are there. Now I am going to take that one. Brown is the first one, first column. Green is a 5, first column. Black 3 is the first column. And orange is the power you can use that one, multiplier. Orange's number is 3. 10 to the power 3 is a multiplier. 10 to the power 3 equals to kilo. And the plus or a minus 5% is the tolerance. You can no need to add it or subtract it, no need of that one. After the gap that gold will come, you can 150 kilo ohm you can consider. Andre a band the hindiನ number a gap the hindiನ color ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ multiplier ಆಗಿರುತ್ತದೆ. Next one is a red, black. Red is 2. First color and the second of color is in the column 1. It is 22 into 10 raised to 2 equals to 2200. We can convert it into the kilo ohm. It is a 22 kilo ohm, 2.2 kilo ohm. It is the symbol of the register I have given. Band. After the gap, the tolerance number will come. Whatever the color will come, it just no need to add or subtract. Exact value no need to calculate. Just the approximation value you can calculate in the laboratory also. You can first we have to concentrate on the first, second, third, and the before the gap we can count it correctly. And the second one they have given the one more figure. It is like that. It is the 4 band, 5 band, and the 6 band colors. Example I have given there. Examples means color coding I have given there. You can see in the picture. Capacitor. I have already explained the definition of the capacitor. It controls the flow of charge and it holds the charge, and whenever we need it, it can released. It is the capacitor. Many of the types of capacitors are there. Paper capacitor, ceramic and plastic. In the ceramic, they have given the some numbers: 100, 101, 102, 103 and 104. These are the 5 colors, 5 numbers they have given. How to calculate the capacitor value? In the 3-digit capacitor code, it is the first 2 digits are the capacitor value. In the third value, it is in picofarad. The third digit of the multiplier factor of the first 2 digit. Calculate the final capacitance value of the capacitor. And the first 1 and 104 I have taken. First and the second value is take it as a combine. 1 it is there 11, 1 it is there 15, 33 it is there, 3 it is there 33. We can consider it like that. And the third value we can take it as a power. 10 to the power 4, 10 to the power 2, 10 to the power 3, whatever it is there, you can take it and multiply it. And last one is take it for the constant of the capacitance value. That is the 10 to the power minus 12 is a constant. means 104 I have taken here. 10 into 10 raised to 4, 10 raised to minus 12 means 10 raised to 5 into 10 raised to minus 12 equals to 10 raised to minus 7 means 0.1 into 10 raised to minus 6 we have taken. 10 raised to minus 6 means microfarad. Microfarad means it is farad is the unit of the capacitor. At the same way 102 it is there. 10 into 10 to the power 2 into 10 raised to minus 12. 10 raised to minus 12 means 10 into 10 raised to minus 12 into 10 raised to plus 2. It is the 1 nanofarad we can use like that. It's the same way we can calculate the value of the capacitor. We are going to study about the importance of the electronics. I have already explained at the present days in the many of the sectors we are using the electronics. Without the electronics we can't live at present days. TV, mobile phones, switching, refrigerators, mixtures, everywhere the electronics is there. The main importance for the electronics is what are the processor importance in the electronics is first one is a rectification, amplification, control devices, generation of the electronics devices. It is the main use. First one is a rectification. Rectification means conversion of AC to DC. Call it as a rectifiers. This process is called it as a rectification. This DC supplies means the DC supplies the main usage of the rectifiers at present days. Using the DC supplies we are using the charging batteries or mobile chargers. We are using the DC batteries. And the next one is amplifiers. Amplification process is the main important. For example, sounding systems, signals, radio system or a sound in the TV or in your theater, they are using the amplifiers. Means they are using the amplifiers means increasing the strength of the sound system. Wherever you can use the sound system, it is the amplifiers are the main importance. Next is the control devices. Control devices, it is the main role. It is the how much we want to voltage, how much controls the facility. It is we are using the control devices. And the generation of the computer, it is the controlling the electronic devices. It is the main, it is the conversion of AC to DC and the DC to AC. Inverters also we are using. Inverters means conversion of DC to AC in your solar system. Solar is a DC source. It converts into the AC, alternating current. It supplies all over the home facilities we are using. This is the main importance of the electronics is. It is the main device wherever you can controls. In your control devices are your mobile phones, networks. These are the control devices. For example, if you send any messages, it send it to the network center. If it is the good message, they can send it. Otherwise, it is corrupted. They can't send it. These control devices we can use in these devices. Sources. In the electrical and the electronics, sources are the main important parts. These are the two types of the sources. One is a voltage source and the current source. In the voltage source and the current source, there are the two types, ideal and the practical. First, we are going to study about the voltage source. Voltage source means any device that produces voltage output continuously is known as a voltage source. There are two types of voltage sources, namely direct voltage source and the alternating voltage source. Means the voltage source is device that produces the output continuously. Means if you are giving the input of that one, it is the you can get the output continuously. It is the meaning of the voltage source. And voltage source, there are the two types. One is the direct voltage source and the alternating voltage source. Means the DC voltage source and the AC voltage source. In the ideal voltage source and the practical voltage sources, the ideal voltage source is an independent voltage source. It is not depend on the any of the component. Practical means it depends. Means now we are going to study about the DC voltage source. Direct voltage source. Direct voltage source, a device which produces direct voltage output continuously, is called as a direct voltage source. The common examples are cells, batteries, DC supplies. It maintains the same polarity of the output. Means like that the negative positive it is the current is flowing from negative to positive. It is called it as a rise in a voltage. The voltage is the current is flowing from positive voltage to negative. It is the fall in the voltage. Here to calculate in this circuit negative and the negative, e.g. is a power supply. It is the positive of the supply current flowing through the circuit with a load resistance RL. The current is measured as per the Ohm's law. V equals to I into R. I equals to V by R. Ri is the internal resistance and the RL is the load resistance. The load current equals to E equals to Eg divided by RL plus Ri. Eg equals to the power supply 1 and the power supply 2 equals to Eg. Eg equals to E1 plus E2, we can take it. And the voltage as the same Ohm's law, we can apply it. Eg minus I into Ri equals to IRL. Is a IRL means load resistance and the flowing in the current I. It is called it as a direct voltage source. It is the positive and the negative terminals remains the same. Remains the same means if for example E1 it is the negative supply to positive. It is the rise in the voltage. If in case positive supply in the second and the negative it is there is no voltage supply in this circuit. Alternating voltage source. Alternating voltage source means AC supply of the voltage source. Where we have to use it, it is a generator we can use for like that. Means a device which produces the alternating voltage continuously is known as a alternating voltage source. For example, AC generator. In your home, if you take the AC generator, the power supply will turn off. Automatically the AC generator will on. It is the process of the continuously the voltage will provide in the output. The voltage source is that it periodically reverses the polarity of the output voltage. Means it indication in the sine wave format. The symbol of the AC is circle with the sinusoidal wave symbol. It is when the load impedance in the DC we can use it as a resistance. Here the AC we are using the impedance ZL is connected across the source. The internal impedance is called it as a ZI. Across such a source, current flows through the circuit that periodically reverses in the direction. This is called as a alternating current. Load current or a RMS equals to Eg divided by ZL plus ZI. Thermal voltage equals to Eg minus IZI, otherwise V equals to I into ZL. We can take it. This is the definition and the formation of the alternating voltage source. Constant voltage source. Constant voltage source means the ideal voltage source. Ideal voltage source means it is using for the ideal voltage sources. It is the constant voltage source, means if you give the 5 volt of the supply without any maintenance, otherwise without any disturbance, you can get the same value of the output. Why? Because of the getting that's the same voltage, because of the internal resistance. The internal resistance is very small, that's why the load resistance is very high. That's why you are getting the constant voltage. If in case, but in the other sources, if you give the more internal resistance, the voltage will be decreasing. A voltage source, the definition is a voltage source which has a very low internal impedance as compared with the external load impedance, means internal resistance is less than the load resistance, is known as a constant voltage source. In such a case, the output source is nearly remains the same. When the load current charges, means when the load current is charging, that time it maintains the constant voltage source. You can see it in your car driving. It is the charging batteries. When you are driving in the straight line, it is the 12 volt it is there. You can maintain the same voltage. If you take that turns, it is starts absorbing. That is the constant voltage source. It is the main usage in the batteries. The difference between the ideal and the practical voltage source: when the internal resistance is very less in the ideal voltage source, you can get the constant voltage. If the internal resistance is high, that's why you are connecting the resistance also in this practical voltage source. The practical voltage source voltage is decreasing, and with respect to increasing the current. These are the two differences you can get through the graph.